Beholdeth, I shall make this shine like the sun.
Okay, in this episode we're going to be covering spark plug gaps, how to set your spark plug gap, also more on CDIs and the do's and don'ts and what makes them fail. Okay, I've had to go to a whiteboard to try and explain this. It's just the easiest way to do it. So I've got a little sketch here of a spark plug. Here's the gap which you measure between the electrodes. This is the earth electrode and the positive electrode. So the original Lambretta spark plug gap is 0.5 millimeters. That came out on every model, all had the same spark plug gap. But most common used at the moment by nearly all the workshops in the UK and Germany, wherever, is 0.6. So what they've done is they've increased the gap, because now we have a little bit better ignition systems. So they've increased the gap, opened the spark a little bit more to the flame to give you a better burn. The maximum gap you should be able to go to is 0.8. This is going to open up the spark more. It should burn more fuel and more efficiently, but you're on the edge, because increasing gap then increases load on your ignition coil, because it's producing more voltage. When it gets up too high, that's when you start getting problems. So beware. 0.8, the maximum. You start going above that, you're putting too much stress on the ignition system. Well, hello there. I just went out and got myself a brew, and I watched a bit of Kickback Garage, and I must say I'm really jealous of his BSA. It's looking brilliant. I'd like to promote him as well, because he's pushed me and asked his followers to come and watch my channel, and well, I've got to do the same back, man. You know what I mean? Anybody who watches me, they need to watch Kickback as well. He's a great guy, and he does some really professional work, and his camera work's damn good as well, even though I'm trying to get mine better. But it's early doors, and we're only just starting, so let's see how far we get. Let's carry on with another little project. I got this today through the post, my Kawasaki filter. It's off a motocross bike, and this is another future project that I'm going to do. It's going to be fitting on the inside of the side panel for a TS1, because there's very little room between the side panel and the carburetor. So, and all the filters I've tried, nothing works properly. So I'm going to develop this one with a backing plate with an inverted venturi, and then it'll be tested, and I'm thinking it's going to be good. So after this we'll go back to doing some CDIs. See you in a bit. Okay, here we go. Here's a little drawing of a CDI that I've just sort of mocked up. Probably stole it from somebody on the internet, but it's basically I've modified it a little bit so it's more like a Lambretta ignition. So we've got source coil, which gives you the voltage, which manufactures our voltage that goes up to our capacitor here inside the CDI, and we've got the pickup coil, which is also on your stator plate. That is your trigger. That triggers the SCR switch or thyristor. What happens is the source coil charges the capacitor. That increases in voltage, stores it up, and then it's released when your pickup is activated. So as your flywheel comes round, comes in line with the pickup coil, and your ignition timing lines up, bang, opens this switch, discharges the capacitor into your first coil, your primary coil. The charge from that one is then amplified by the secondary coil, by the secondary winding, and then it discharges to your spark plug, and you get a nice big fat spark. Bob's your uncle, CDI. Hi, and welcome to the end of my video. I hope you've all enjoyed it, and if you're going to give me a big fat thumbs up,
and subscribe to me. I'm just going to at the end recap on my earlier video in part 1 where we were discussing damage to CDIs via shunt resistance from resistor spark plugs. So I did get a reply back from an email that I sent to Vape, and they said that in their instructions it says use non-resistor spark plugs, but do use resistor plug cap. So I'll leave it at that. You can work it out for yourself what you think. If that's what the manufacturer says, then I think my theory was correct about the shunt resistance. Anyway, have a great time, and don't forget to subscribe and give me a thumbs up.